We need to recall few things and we need to know few words before we start off with the next topic. So we are starting off with recalling conductor. So conductor in terms of electrons are scenarios wherein the electrons are loosely bound to the atom and they can move freely throughout the metal. When it comes to surface potential, we actually know this, that if you have certain charges within the material, what happens within a conductor, the potential will be uniform throughout. Similarly, if you look into insulator in terms of electron and surface potential, electrons are tightly bound, not free to move, not that free. While we talk about surface potential, what happens? They can be concentrated. They need not be uniform. Right? For example, if you take up a scale, rub it against your head, hair that is, and get a small piece of paper near it, it will get attracted and all of that. While if we take the same scale, just turn it around and try doing that, it won't. Nothing happens. Because the potential is not spread across. Free and bound charges, we kind of got a hint about that. We already know this. So free charges are one which are not bound to any particular atom and they can move freely within the material. So example, metals, right? But this is what is important, the behavior. When an electrical field is applied, the free charges move in response to the field, creating a current. So they respond. Of course, actually, all the charges respond. Here, the response is a lot more noticeable in terms of current. While in bound charges, the behavior is such that we see a slight shift within the atom or molecule and all of that. So things get polarized and there's no flow of charges per se. Right, guys? And one last term. So you guys have heard of this term, electrolyte. So we are having a conductor based on that. So basically it's to do with ions. A material that conducts electric current by the movement of ions. So how does it work? Well, when we have electrolyte dissolved in water, we have the positive and negative ions. These ions move towards the electrode, respective electrodes, allowing the flow of current. Basically movement of charges. For example, if you take up a salt, table salt, and say we have water, pure water, just S2O, nothing else. You dip two electrodes connected to a battery and a light, nothing happens. But the same system, when we add salt to the water, what happens? It starts conducting. Right? I hope you guys know this experiment. It's quite simple. If not, just rewind a bit, or you can just web search, you'll get this experiment. It's not that hard. Okay, yes. So if you guys want to write, you can write. If not, it's okay.